Find the integral of 24x minus 12 over the quantity x squared minus 2x minus 3. Okay, so first thing to notice here is you can probably break this up into two polynomials. We can also factor out a 12 up here. Oop. And so we're going to rewrite this as, let's try integral. We'll do 12 out here, 2x minus 1 over x minus 3x plus 1. So I know there's going to be a 3 and a 1 because the factors of 3 are 3 and 1. And we know it's going to be negative 3 because when we add them together, we get negative 2. So it means that we're going to have negative 3, positive 1. And from here, another thing to check to see if we take the derivative of this, if this gives us the top one, which it doesn't. So it looks kind of like what we're going to have here is a partial fractions. Okay, so when we take the integral of this, we get 2x minus 1. No, 2x minus 2, which is close to 2x minus 1, but not quite. If it was 2x minus 2 up here, then we do u substitution, say u equals the bottom, and everything would work great. But not quite. So what we're going to do here is I'm going to take this fraction right here and try and break it up using partial fractions. So we have 2x minus 1 over x minus 3 times x plus 1 equals, I'm going to make sure not to forget about the 12 I have over here either. So this is going to be some a over x minus 3 plus some b, which we'll find, over x plus 1. Forgot the little 1 over there. So I write it like this. There's a couple other things if you have like quadratics or if there's a power to one of these polynomials. And you can look that up. But for here, since they're just simple polynomials, we'll leave it like that. And then we recombine it. So to combine it, then we'll do a times x plus 1 plus b times x minus 3. What we're doing here is we're trying to get a common denominator because we had a common denominator over here and we're trying to get back to that. So this is going to be x minus 3 times x plus 1 on the bottom. It'll be the same thing over here, then we'll just combine it. So I'm skipping a couple steps, but if you're familiar with algebra, you'll see it. If not, you should probably take a look and understand how I got there. All right, so then I'm going to factor out the x's. So x times a plus b plus 1 times, let's see, a minus 3b. You're like, wow, that's a funny way of writing it. And then this thing goes over here. Well, what that tells us then is we have this 2x over here, which is going to have to equal this a plus b over here. And we have that 1, negative 1, which is going to have to be this part over here. So when we rewrite this, well, we're not going to rewrite it. I'm going to sidebar, so to speak. So we know 2x equals a plus b times x. And we know that negative 1 equals a minus 3b. And I could say times 1, but I'm not going to just for simplicity. So we know that x's cancel. And we have a equals 2 minus b. Okay, we come down here, plug this 2 minus b in for a. We have negative 1 equals 2 minus b minus 3b. Negative 1 equals 2 minus 4b. 4b equals 3. Therefore, b equals 3/4, and a will then be 5/4, because 2, which is 8 over 8, minus 3/4 will give us 5/4. All right, so now we know our a's and b's, and we can plug it back in. I'm going to go straight over here to plug it back in. So this will be 12, don't forget the 12, integral, and we're going to write it of this form like this. So we know a is 5/4, so we have 5/4 times 1 over x minus 3. I just moved the a over there. Plus, and I'm going to break these up a little bit. So 12, b is 3/4. So we have 3/4 over 1 over x plus 1 dx. Now, these would be solved by substitution, but what you would find I'll cancel some of these out. 12 divided by 4 is 3. 12 divided by 4 is 3. Is the integral of 1 over x minus 3. You could say u equals x minus 3. And then you'd get a natural log scenario. So this will be 3 times 5 natural log of, and this absolute value bar sign, x minus 3 plus, nope, I forgot the 15, because 3 times 5 is 15, plus 3 times 3, which is 9, times natural log of x plus 1, absolute value bar sign, plus c. And so that's how you would approach this problem using partial fractions to decompose your fraction. Pretty straightforward once you've done it a few times, but if you don't really recognize it at first, it can be really confusing, and there's quite a few steps, so it takes a significant amount of time, even though the problem itself no single part of this problem is all that complicated. So another complicated thing to know is the integral of 1 over like x plus 1 or x minus 3 will be similar to 1 over x, which will then give you a natural log of what's on the bottom. So I hope that helped. See you next time.